Hey logicians, this is your Professor O, and I'd like to go over the practice questions with you for the midterm. Try to make up for the time today that I was going to spend kind of talking about how to approach these questions. I'm sorry if you're not able to ask me the questions that you would like to ask. I am by my email though, and I'm trying to answer them as adequately as possible through that medium, okay? But here you just kind of have to start things off pretty easily. You know, looking at these things, you just have to, discern whether or not they're an assertion. Don't always trust, right, the punctuation. Like, obviously, this is an emotive exclamation. Emotive exclamations, remember, they're kind of like boo, yay statements, all right? And so here, yuck, right, that's kind of equivalent with boo. All right. Yes, I do see that there's a period here coming after the question mark, but it's obviously a question, so it's not an assertion. Okay, watch out for the man around the corner. I know you see the exclamation point. You might think, oh, that's an emotive exclamation. But it's not, because watch out for the man around the corner. Yay, boo. That doesn't really make sense, all right? What it is actually a command that's just spoken loudly, all right? So if you put an exclamation there, that's not right. That's a command. Right? That's the one tricky one I wanted to go over. Also, to the last one, I don't like it when people hide around the corner. That is an assertion. People could be lying about that. All right, moving on. So the good old recursive definition questions, all right? Here, these are the questions that are about syntax. So you really do need to slavishly follow the rules about all the symbols and how they're arranged, because that's what the questions are asking you. Some of you were diligent in pointing out that in some of my problems on semantic properties that the parentheses was missing here or there. And I didn't give extra credit for that because, for one thing, it didn't really matter to the problem. It was evaluating for semantic property. And you could be able to figure that out without having to have it technically well-formed. And so I just kind of let that go. I give myself grace on that because then I don't have to post it 4 times again. All right. So, but thank you for pointing that out. You are very smart. You should, give yourself credit for following the rules of syntax. All right. So that's good. And so apply that kind of skill to this kind of problem. Right, here's your alphabet. You got the numerals, a little x, and then both of the parentheses. Here's what you can use for your simplest expressions, all right, 0 through 9. That's permissible, and then we'll let P and Q just be any of those, all right? However, you can't start a sequence off using 0, okay? That's not going to work, all right? Then P and Q is permissible expression, so you can kind of stick them next to each other, and that's fine. Then you can have P, X, Q inside brackets, that's also permissible, and then nothing else is, all right? So this follows the rule right here of just doing the PQ thing. You can put 1 with 2, and then 12 with 3, 123 with 4, 1,234 with 5, right? You kind of see how that goes. But this doesn't follow the rules because one of our expressions here starts with 0, and that's not allowed, right? That's just not allowed. Also, too, we don't have outer brackets, okay? Gotta have that. This is a syntax question, so, syntax rules apply. We gotta be sticklers on this part, okay? All right. 2 X's together, that's a fail, and this is all good. I know you probably might have seen the space here. Don't worry about that, you OCD people. It's okay. All right. Again, this kind of a question, right? You just tackle this. 3 or more occurrences of X. Is this property syntactic or semantic? Well, that's syntactic because it has to do with how things are arranged. How things are being arranged? Well, you have 3 or more X's in your formula. Okay, this question is just about semantics. It's just kind of getting you to think about, like, how would you make sense of this, right? And given you all have math backgrounds, you could see that this could probably represent multiplication, all right? All right, this is pretty straightforward. I don't think I need to go over that. Thank you to the person who found the wrong answer that I gave to here. I was missing, what was it? I think it was a Q arrow Q in one of these, like that. So thank you for that. All right, just note, you can kind of see how this like really big antecedent is a sub-formula, right? And then you got to kind of pull things out of that, right? So you're going to have P arrow Q is in there. Let's see. Oh yeah, so this whole thing, right, is a conditionals. So then you pull out the antecedent there, you write it right there. That is it's quite an annoying problem, right? All right, so here we're back to CL star. CL star is kind of nice because we just have FA and GB, right? We can do, I think, A and B and F and G. That's what we have in our alphabet for CL star. And also thanks to the student who helped me correct this part of the problem. I think this example right here was incorrect on your original document. If you printed it out, just note that I did put up updated files up online, so everything is correct in light of the feedback that I've gotten. So thank you for that. I try to update it immediately. Okay, that's something I do. And here you just have to determine whether or not things are true or false. And you remember how this stuff works, right? And this is a complete model, by the way. You have a domain, right? You have predicate functions and you have term functions, and they're all filled out correctly. Note and just observe how they're filled out correctly. Right? Your domain is in the normal set brackets, so are your predicates, but your term functions only have one thing, and they're not in brackets. You need to fill things out correctly like that. Okay. All right. So then you just kind of determine what's true and false, right? And so you can do that with this model here. Is B in F? Right, B is 4 in F? No. Okay. And so on and so forth. And you just kind of figure out what's true and false right that way. All right. Now here you're telling me whether or not things are well formed or not in TFL. All right, so something like this is not going to be, because names can't just stand by themselves, right? P is not in the alphabet. Now, if you were trying to figure out what the main connective of this is, it's right here. Remember that with negations, they're tricky like that. Okay. This is actually well formed. You can do this, even though this looks kind of silly, but that's actually okay. That obeys the rules. All right, let's just make sure I'm tracking with the answers there, making sure there's no disagreement. Okay. No, this is not well formed because there's an unmatched parenthesis. It's you gotta be tricky there. Okay, so there you go. All right, figured these things out. Okay, remember, right? Everything that's negated is a sub-formula. That's the one thing you gotta remember about those. Okay, and this you should. Okay, if you don't know these things, you're just gonna get an F. All right, you will fail the exam. So make sure you know those, okay? And then, all right, here we go. Question 9. This is where students were getting tripped up a little bit on Monday when I was talking about this kind of stuff. This is asking you, suppose we're going to evaluate the argument for validity, and you don't have to do that, right? You don't have to do that. I don't care about that. All I want you to do is write down a complete and adequate and not total model. Now, a total model, you might be wondering, what's that? You know, that is a very large specification, okay, that could give you an answer to any conceivable atomic formula you could generate in TFL. Now, there are a whole boatload of those, all right, and I don't know how many. I've never tried that, okay, and so to ask somebody to do that would be just totally unreasonable, all right? So we're not interested in doing that, but that's what that means if you were wondering. All right, let's see here. So what is an adequate model, for one thing? Well, an adequate model is something that just assigns a T and an F to each of your atomics, okay? Now, what's a complete one? Well, a complete one is one in which you specify a domain, predicate functions, and term functions, all right? Now, if you're still confused about that, I would just ask you to revisit the textbook, all right? And here we are, page 7 on chapter 4, 4.3. We go over complete models. All right, and it piggybacks off of what we learned in CL star. So just recall that. And the only thing you have to remember that's different about TFL is that we are not really restricted at all to just 1 degree predicates. Now we have multiple degrees, okay? We have things like relations. So the basic idea behind a complete model is just the same as CL star. We construct models by indicating a domain of individuals along with extensions for each predicate and reference for each name. However, now we got to take into account the possibility of predicates whose degree is greater than 1. In order to do that, we introduce the idea of an ordered set. And that's just a list of items in a particular order. So ordered sets differ from mere sets in that mere sets are just a collection of things. They're not in any particular order. So this like one right here, Boston, Charleston, and Detroit is exactly the same as Charleston, Detroit, and Boston. Okay? That's just a mere collection of things. But an ordered collection of things, or an ordered set, comes in a particular order, and so we denote that with angle brackets. So Mary, John, and Jose is different from John, Jose, Mary. Okay? All right, so now when you are filling in your extensions, and I'm going to go over this question here, right? A complete model is just this, right? Domain, predicate functions, term functions. So for my domain, I wrote down 1, 2, 3, 4. Okay, my extensions of my predicate, they have to be full of something. Okay, they can't just be empty. I'm not going to allow that on this exam, right? Empty sets are perfectly valid, right? They're well formed. But if I were to allow you to write empty sets, I wouldn't be testing your knowledge on how they work. Specifically, what's the difference between, right, the G predicate and the L predicate? Right, and the G predicate is just a 1 degree predicate, so you can just list one thing in there, right? They got to be in brackets. That's all good, right? But for L, okay, now we have 2 places that names can go, right? So you have to specify then where things are going, right? And you use the angled brackets for that. Okay, so here's what I'm talking about, okay? This atomic formula is saying, right, that, I mean, it's basically saying this, L, 1, 2, right? Because A refers to 1, B refers to 2. Now, I just asked myself, is the pattern 1, 2 in the extension of L? And it is. There it is, okay? Now, down here, this is saying L, 2, 1. Now, is the pattern 2, 1 in here? And the answer is no. Okay, so that's not going to work, right? So this one's going to be false, while this one's going to be true, right? Of course, D is not in the extension of G, so that one is false as well. Okay, that is a complete, adequate model, right? And that's all you got to do. You got to fill it out like this. Okay, so make sure you do that. All right, for question 10, each of the following formulas, I'm just going to do 10D as my example, but here you have to make a truth table indicating which semantic property applies to the formula, all right? Is it logically true, is it logically false, or is it logically contingent? Now, you should just have this memorized, right? And you remember what logical falsehood means. That means false under the main connective of every row. Truth is true under the main connective of every row. And contingency occurs when you have a T under the main connective in at least one row, and then an F under the main connective in at least another one. Okay, so going back to the way I filled this out, all right, let's just kind of look at this. All right, so what I haven't completed it, right? I need to solve for my main connective first because this ampersand is the main connective. Right, so let's do that. All right, let's now make sure I got to get this part done. So let's just bring the good old K formula over here. I think I did this at one point, and then I for whatever reason I deleted that. But let's just kind of look at this. Okay, so this is going to be true. We got a true and true. Okay, good. True and a false. All right, so that's going to be false. Okay, and then I got false antecedents all the way down, so that makes this all true. So that's good. Okay, that part's done. All right, so now I'm in a position to evaluate for my main connective. So I see that I have a T and an F, right? And conjunctions are false if just one of the conjunctions is false. So that's going to be false. Okay, that's going to be false. It's going to be false. And oh, look at this, it's true. Okay, now I can be done. Okay, I can actually finish. I don't have to finish the truth table because I found at least one row where there's an F under the main connective, and another one where there's a T, and so that should tell me right away that it's logically contingent. Okay, going back to our handy-dandy, trusty little slide here, that's exactly what contingency requires. All right, question 11. For each set of the formulas below, make a combined truth table and indicate whether the formulas are logically consistent or inconsistent. Okay, so here is the deal, right, with consistency. Now this is the main connective of this formula, so that's why I have it written that way, right? And then here's the main connective of the other formula. Now, are these consistent? And yes, they are. In fact, I probably could have just stopped at this very first row, right? So I'm going to highlight, I'm going to make this red, all right? And then I'm going to make this one red. Highlighter, there we go. Right, I could have stopped right there, actually, because that's where they're consistent. Okay, now what does consistency say? Right, consistency just means that your formulas are all true together in some row of the table. Okay, they're all true together in some row of the table. And so you can see that, right, in the very first row. The reason it works that way in the first row is because anything in my formulas here, there's no negations anywhere, right? So that's a handy tip. Okay, and I think there's other places where this is consistent as well. Yeah, here we are. Oh. Okay, so there's multiple ways this can be consistent. Right? I'm not looking at the atomics over here, right? I want to know about the main connectives, okay, of my formulas. Right, this one's inconsistent, right? Right, here we're looking now, what's inconsistency? What's that amount to? Oh, that's not the right slide. That's not it either. There it is. Okay. Inconsistency occurs when your formulas are never all true in the same row of the table, right? So you never get that nice pattern. What I'd like to see for consistency is T, 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 but I never get that, right? There's always a falsehood somewhere here. So in every row, I never get a row of all T's, okay? That just never occurs. So it's inconsistent. Again, I'm evaluating these formulas, right? Doesn't really matter what's going on over here. Okay. 12. For each pair of formulas below, make a combined truth table to indicate whether the first logically entails the second, or whether they are logically equivalent. Okay, so when you're reading this thing, you see that this is a set, okay? Now, it's not an ordered set, so, but for purposes of the question, you can just look at the very first thing that's listed and then ask, okay, does this thing entail the second thing that's listed? All right? And so there we have it. Okay, so I have two main connectives here. I have the biconditional and then I have the conditional. And I have that all filled out. I had to correct this one, and I did it. All right, and I think this actually tracks the way it is in the answers. This is what, 12D? Just look at that, make sure we're doing it correctly here. Oh, come on. What do you mean, whoops, there was a problem? All right, there's my 12D. There's the entailment, and that's exactly what I got right, when I filled this out correctly. Okay, so what is entailment all about? Okay, well, one thing you can remember is that whenever this one is true, then this one is true. Okay, that's what entailment means. All right, whenever this one is true, then this one is true. You can say then that this formula then entails this one. All right. So that's what we're looking for. So whenever this is true, and that's why I've highlighted the T's in red. So whenever this is true, is this one true? Yep, it sure is. Okay, so entailment holds, all right? Entailment does not hold if I were to go from a truth to a falsehood, all right? Now, you don't worry about, like, what about where it's false? You know, just who cares? It doesn't matter, okay? Right, and that reflects what you're instructed to do, right? So entailment, remember, is that there's no row where there's a T under the main connective for P, but an F under the main connective for Q. And that's exactly reflected in this. There's no row where that happens, where there's a T, right, and there's an F, right? So whenever this is T, this is T, okay? However, equivalence does not hold because, well, there's not a match, right? Like here's where things go wrong. All right, this would have to be F, and then these two would have to be F in order for equivalence to hold, but it doesn't. Remember, equivalence is an entailment going both ways. So this would have to entail this, right? Problem though is that you go from a truth to a falsehood, and that once that happens, okay, once that happens, right, then entailment doesn't hold. At least going from this, so from going from this to this, right? It's directional, okay? That's one thing that I think students get really confused about, is that this is a very directional property, right? But the first, right, does entail the second, and we've proved that, okay? Whenever this is T, right, this is T. Right, I hope that clears up some of the confusion about that. All right, for validity. Now, validity is just an entailment relation between your premises and your conclusion. Okay, so I write this out like so, okay, and I fill in the table like that, right? And I think this is consistent with the answers. Oh, that's good. Let's just make sure so that you can keep me honest. Yep, that's exactly what you get. That's what I got too, all right? Now, I've highlighted things in red here because those are the rows where my premises are consistent, meaning they are both true together, okay? Those are the rows that matter. I need to pay attention to those, okay? And then I look and see, is my conclusion true as well? And it is. In fact, whenever my premises are true, okay, so is my conclusion, right? And I don't even bother like filling in these other ones, right? Because those, I don't care about those, all right? I don't care about those. And the reason I don't care is because these are the rows where my premises are not consistent, right? I don't care about that, okay? Validity, again, is an entailment relation between premises and conclusion. So what I care about is moving from truths to a falsehood, and that never happens, okay? That never happens. And so that's why I'm able to show that validity occurs. Right? And that works. That's an adequate proof. All right, and then number 14, here we are. We're going to do a constraint problem. You're a distribution manager. Choose 3 of 4 possible routes. All right, let's see. Now, you have to choose 3 of 4. Okay, so that's your numerical constraint. Let's just kind of note that. And we got 3 choices. Actually, no, we got 4 choices. So this would have us make a 16-row truth table, which is kind of onerous and awful. And that is completed in your answer sheet, by the way. If you go to question 14 here, you'll see this fatty boom batty truth table right there. And, you know, okay, if you fill that out, good for you. Gold star. But you actually don't have to do that, right? This one's one of these sneaky problems where you just say, I have to choose 3. All right, well, I'll note that, okay? Let's translate our constraints. These are really easy. They're just nice if-then statements, okay? You don't have the then here, obviously, but that doesn't matter. You can still kind of figure out what the consequent is, right? English doesn't always use the then. So if A, then not B is allowed, okay? And then, of course, if C is allowed, then either D or B is, or both. Okay, so that's going to be an inclusive or, so that's your consequent. So there you are, right? You got your numerical constraint 3, and so here's what you do, all right? Here's the fatty boom batty truth table. Okay, notice how there's 4 rows that have 3, okay? You can actually just do those rows, right? And how do you do those rows? Okay, so now here my truth table is only 4 rows long. Now, how did I do this? How did I come up with this, right? Well, I just grabbed the rows that indicate 3 choices are being made, right? And so here's the atomic part of the truth table. Now notice that row 1 is A, B, and C are being chosen. So those are 3 choices right there, right? Then the next one, you just move the F over one more slot. You kind of trade places with the F and the T, all right? So, okay, so now you have A, B, and D being chosen, right? You just move the F over once more, and you got A, C, and D being chosen, and then of course you just have B, C, and D being chosen. And then you just do your truth table, okay? You just do it, all right? And can you satisfy all your constraints? Well, not in the first 2 rows, you can't, but you can in the last 2 rows, all right? So you're good there, and so then what you write down are the 2 options that you can take. You can take A, C, and D, or B, C, and D, and that's what we've done here. That's what we've written down. Okay, that's what they've told us to do. All right, so that is the way you do this. Okay, that's a nice shortcut. All right, some of these problems are tricky to interpret. This one is especially hard. I think I got a nice question from a student about this. And you might be thinking, well, how do I translate this? You will choose one and only one dinner. And you might be thinking, okay, how do I put this in TFL? That looks like a biconditional. Actually, you don't need to do that. Just think about it for a moment. You will choose one and only one dinner. So how many dinners are you going to choose? 1. All right. So that is actually going to be your numerical constraint, right? You're going to choose 1 dinner. So just list that as 1, all right? This is tricky to translate. Either see a movie or live music, or neither, but not both. Okay, that's a lot of ors. You could write 3 ors, all right? And then a conjunction, right, indicating this. That'd be a nice, long, awful-looking formula. But really, this is just describing a negated conjunction, right? You can see a movie, a live music, or nothing, but not both, right? So you can't see both. So that's just a negated conjunction. If you think about it, you'll see why. Okay. All right, so there you are, and that's the answer. Okay, you can take a look at that on your own time. This is also a tricky question. Okay, and the big problem here is this: if more than one project is developed, the expected revenue is the average of the 2. Right. So if you are choosing, let's see, project A is $500. So if you choose like both A and B, all right, suppose you choose A and B, that's going to add up to $800, but and then you have to take the average. So that's going to be 800 divided by 2, that's 400, right? And that's reflected down here in the stupid truth table, right? And so that's why that's written the way it is. So sometimes you have to do a little math like that to figure these out. Okay, and I think only project A only. I don't always really like this question because I think it's just kind of silly. You probably figure this out without having to do any of this. But if you're looking for extra practice and just how to set these things up, this is a nice problem. So that is it for the video. I hope this was helpful. This was going to be my lecture, and I was going to take questions from you. The lecture would have gone longer because I would have had to fill out all this stuff, and I probably would have done it wrong. So I'm glad that I had the time here to kind of figure this stuff out. But that is my tips for approaching these things. Please, please, please email me today, which is Wednesday, or Thursday. That's fine. Okay, and then I'll see you on Friday, and we will get this thing done. And I'm very excited. I think that you all will do pretty well. I think you're going to study hard, and do your 30 minutes, an hour a day working on this stuff, and you will be good. One thing I might do is I think I might today just put up some more translation questions for you all, because I think it's good to kind of get to know this page right here better, and just getting better at translation. That can be good. But I think what I've given you in the slides and the practice problems is certainly going to be adequate for the test. The translations on the test aren't like super complicated like they were in the homework. All right. Okay, so that I'm coming up on minute 30, so I hope that you have a wonderful day. Stay dry. It's raining here in Columbia. I don't know what's going on in Clemson, and stay healthy. Right? I'll be back 100% soon enough. Right? Take care.